The story of electric vehicles is a captivating tale of innovation and perseverance. It's about harnessing the power of electricity to propel us into the future. But this journey didn't begin with sleek modern cars. It started with a spark, an idea, a dream of a different kind of transportation. Imagine a world before cars, a world of horses and carriages. In this world, inventors dared to dream of a cleaner, quieter mode of transport. Their vision? Vehicles powered by electricity. These early pioneers laid the foundation for the EVs we see today. From rudimentary electric carriages to the first electric tricycles, the seeds of a transportation revolution were sown. The 19th century became a breeding ground for ideas, a testament to human ingenuity and the relentless pursuit of progress. The world of science and technology is built on the shoulders of giants, and the realm of electric vehicles is no exception. Visionaries from across the globe contributed their brilliance to this electrifying field. One such pioneer was Ányos Jedlik, a Hungarian inventor who in 1828 created a small-scale model car driven by an electric motor of his own design. Across the English Channel, Robert Anderson of Scotland developed a crude electric-powered carriage between 1832 and 1839. Meanwhile, in the Netherlands, Professor Strating of Groningen and his assistant Christopher Becker unveiled their own small-scale electric car in 1835. That same year, on the other side of the Atlantic, Thomas Davenport, a blacksmith from Vermont, showcased his own small-scale electric car and made history by inventing the first American-built DC electric motor. These early pioneers, separated by geography but united by a shared vision, set the stage for the evolution of electric vehicles. Their inventions, though rudimentary by today's standards, were monumental leaps forward, pushing the boundaries of what was considered possible and igniting the imaginations of future generations. While the invention of the electric motor was a pivotal step, the true potential of electric vehicles lay dormant, limited by the primitive state of battery technology. Early EVs relied on non-rechargeable electric cells, severely restricting their practicality and range. Enter Gaston Plante, a French physicist who, in 1865, revolutionized the field with his invention of a superior storage battery. Plante's lead-acid battery, later improved upon by his compatriot Camille Faure in 1881, provided a rechargeable power source, breathing new life into the dream of electric vehicles. This breakthrough in battery technology was a game-changer. It unlocked the possibility of EVs traveling longer distances and paved the way for their commercial viability. The electric revolution was gaining momentum, fueled by the tireless efforts of scientists and engineers, determined to overcome technological hurdles. As the 19th century drew to a close, electric vehicles began to capture the imagination of the public. France and Great Britain emerged as early leaders in EV development, pushing the boundaries of speed and design. In a spectacle that captivated the world, the Belgian-built electric racing car La Jamais Contente, designed by Camille Janazzi, shattered the land speed record in 1899, reaching an astonishing 68 miles per hour. Meanwhile, across the Atlantic, America was experiencing its own electric awakening. A.L. Riker's electric tricycle, introduced in 1891, signaled the beginning of a new era in personal transportation. That same year, William Morrison unveiled his 6-passenger electric wagon, often hailed as the first practical EV in America. The dawn of the 20th century saw EVs taking America by storm. In 1897, the Electric Carriage and Wagon Company of Philadelphia launched the first commercial application of EVs with a fleet of electric taxis in New York City. By the turn of the century, electric cars were outselling all other types of automobiles in America, marking the peak of their early popularity. Section 5. The engine roars, the decline of electric vehicles. Despite their early success, electric vehicles faced a formidable competitor, the internal combustion engine. The early 20th century witnessed a confluence of factors that contributed to the decline of EVs and the rise of gasoline-powered cars. Improved road infrastructure connecting cities and towns across America created a demand for vehicles with longer ranges, a need that EVs, with their limited battery capacity, struggled to meet. The discovery of vast oil reserves in Texas made gasoline readily available and incredibly cheap, further tipping the scales in favor of internal combustion engine vehicles. The invention of the electric starter by Charles Kettering in 1912 eliminated the need for the cumbersome and often dangerous hand crank, making gasoline-powered cars more appealing to the average consumer. However, the final nail in the coffin for early EVs came with Henry Ford's revolutionary assembly line production of the Model T. Ford's innovative manufacturing process made internal combustion engine vehicles significantly more affordable, cementing their dominance in the automobile market. Section 6. A resurgence ignited EVs in the 1960s and 1970s. The middle of the 20th century witnessed a resurgence of interest in electric vehicles. Growing concerns about air pollution from gasoline-powered cars and America's dependence on foreign oil reignited the quest for cleaner, more sustainable transportation solutions. In this era of environmental awareness, EVs emerged as a beacon of hope. The Petronic Truck Company, a joint venture formed in 1964, led the charge with its innovative electric trucks. Petronic's commitment to electric mobility extended beyond trucks, as the company also produced electric utility vans and passenger buses throughout the 1970s. The 1960s and 1970s saw the emergence of notable electric car models like the Sebring Vanguard City Car and the L-Car Corporation L-Car. These compact EVs, boasting top speeds of around 45 miles per hour and ranges of 50 to 60 miles, catered to urban commuters seeking an alternative to gas guzzlers. In 1975, the United States Postal Service joined the electric revolution, testing a fleet of 350 electric delivery jeeps manufactured by the American Motor Company. Section 7. Charging into the future: modern innovations in EV technology. Today, electric vehicles are experiencing a global renaissance, driven by remarkable advancements in technology and a collective desire for a cleaner, more sustainable future. Modern EVs are a far cry from their early predecessors, boasting impressive ranges, lightning-fast charging capabilities, and a plethora of cutting-edge features. One of the most groundbreaking innovations is the development of electrified roads embedded with charging infrastructure. Imagine a future where EVs can recharge wirelessly while driving, eliminating range anxiety and reducing the need for bulky, heavy batteries. This technology has the potential to revolutionize long-distance travel and transform the EV ownership experience. Another game-changer is bidirectional EV charging, also known as vehicle-to-grid (V2G) technology. V2G allows EVs to not only draw power from the grid but also send it back, essentially turning them into mobile energy storage units. This has the potential to enhance grid stability, reduce peak demand, and even power homes during outages. Section 8. A glimpse ahead. The future of electric vehicles. The future of electric vehicles is brimming with possibilities, fueled by ongoing research, technological breakthroughs, and a global shift towards sustainable practices. As battery technology continues to advance, we can expect to see EVs with even greater ranges, faster charging times, and longer lifespans. The expansion of public charging infrastructure is crucial for the widespread adoption of EVs. Governments and private companies are investing heavily in building out charging networks, making it more convenient than ever to own and drive an EV. From ultra-fast charging stations that can replenish batteries in minutes to wireless charging pads that make plugging in a thing of the past, the future of EV charging is both convenient and efficient. The integration of artificial intelligence, AI, is poised to revolutionize the EV driving experience. AI-powered autonomous driving systems promise to enhance safety, improve traffic flow, and provide mobility solutions for individuals who are unable to drive themselves. Imagine a world where EVs navigate our roads with precision and efficiency, reducing accidents and making our commutes more enjoyable. Section 9. Conclusion: driving towards a sustainable tomorrow. The journey of electric vehicles has been one of remarkable innovation, perseverance, and an unwavering belief in a cleaner, more sustainable future. From the humble beginnings of rudimentary electric carriages to the sleek, high-tech EVs of today, we've witnessed the transformative power of human ingenuity. As we stand on the cusp of a new era in transportation, electric vehicles offer a beacon of hope in the face of climate change and our dependence on fossil fuels. They represent a commitment to reducing our environmental impact, creating a healthier planet for generations to come. The road ahead is paved with challenges, but the momentum behind the electric vehicle revolution is undeniable. With continued investment in research, infrastructure, and public awareness, EVs have the potential to transform not just how we move, but also how we live, work, and interact with our environment. The journey towards a sustainable future is well underway, and electric vehicles are leading the charge.